How's it going, YouTube? Welcome back to the Bars Cars YouTube channel. In today's episode, we are going to be back on the 6.2 build, and I'm going to be showing you how to properly clean and prep your block so you can be ready for assembly. So today we're going to be talking about getting your block cleaned up, getting everything ready, clean, get all the shavings and dirt and grime out of it, and so you can be ready for assembly and you don't have to worry about damaging your engine on startup. So for starters, I have the block out here. I have a garden hose. In this tub I have water and a mix of Simple Green. I've already dropped the main caps in here, and what we're going to be doing is, like most of you, I don't have a big parts washer or like a CUDA or something that I can just put the whole block into and turn it on and walk away. So I'm going to be showing you a cheap and easy way that you can do a proper cleanup and block prep on and all of your parts, not just the block, on your build at home. So like I said, for starters, we got the engine out here on the stand, got a hose ready, got a mixture of some Simple Green and some water. And for our cleaning, we're going to be using this right here. So this is a Moroso 61820. This is a big brush kit, so I'm gonna pull them out of here. And so as you can see, we have a bunch of different size brushes. So we can go through, we can scrub out all the oil galleys, we can clean the bores up and get all of the honing grit out of them. We can get everything nice and clean and ready to assemble. Okay, so I got all the brushes out of the box here. Of course, you got some stickers. You got to have a nice sticker stash. You got to represent what you're buying. That's what everybody buys it for, right? We buy the stickers and we just get whatever we order for, you know, whatever. But so we have our bore brush right here. We have a bunch of shorter brushes, various sizes, so you can clean out all those small galleys. We have these nice long ones here, and we're definitely gonna have to use some of these because remember, we have that long main oil rifle that runs from front to back in the block, around the cam, and from the oil pump. So we're definitely gonna need to make use of these long ones. And a little tip that I'm gonna show you here is these have like a little finger ring end on them. Well, if you want to make quicker work of it and, you know, maybe be a little more thorough with your cleaning, we got a drill right here, a pair of pliers, and I figure you can figure out what we're gonna do here. We're gonna cut those ring ends off. We can chuck that up in the drill and spin those brushes as we're running them in and out of the bores and all the oil drillings in the block here. So let's get started. All right, so for starters, we're just gonna give the block a good rinse down. I've got the brushes over there. I got the ends cut off of them and we're ready to start cleaning. So, but as you can see from last time when we were doing some modifying with all the oil drainage and the feeds, that we have some chips laying down in there. So we're just going to start with giving it a good rinse off, and then we'll hit it with the brushes and go from there. So ready. All right, now we got a basic rinse down, got some of the big stuff out of there. We're going to start running the drill and the brush through it, and here's our setup. Looks kind of goofy, a little long, but it'll work great. So we're going to get some soap going on this thing, get it turned up, and start going through the drillings here. You can see we've actually started knocking some dirt loose in there. So I'll put a little bit of a time lapse in here, keep doing that, and you can see what we're doing. And I'll get some more Simple Green in there soaking. We'll go over this, every hole we're gonna go over a few times to make sure we're knocking anything loose, especially when we go through these oil feeds to the mains. We could have had a little bit of dirt get in right there behind the cam bearings. Alrighty, so I've done a bunch of brushing as you've seen in the time lapse. So we've got everything fairly clean now. I'm going to give it a rinse and I'm going to look it over real good. One thing I am going to do too is I'm going to tilt this thing over on either side, and I'm going to show you how to make a quick thread chaser for the head bolts, because if you're not aware, you can even see some of it down in the hole maybe. There is like a sealant slash Loctite that they put on the head bolts from the factory on these, and it will build up and kind of clog the head bolt hole, and it gums up the threads. So when you are trying to torque your head bolts, you can get an inaccurate reading, and sometimes that can actually make such a seal that you'll hear of people talking about the block popping when they're torquing those bolts. It's more than likely because they didn't get those holes cleaned out enough. So I'm going to show you how to take an old head bolt and just cut some slots down the threads and kind of make a homemade thread chaser. We're going to clean all that out, flush them out really good, and clean all the head bolt holes up. I've already ran a brush through the main bolt holes, and I know those were nice and clean. They don't really put a sealer or anything on those, so I know those are nice and clean, and I've ran all the bolts in and out by hand, so I know that they're good and clean. If you have any bolt holes that need chased or cleaned, now is the time for you to go ahead and run a thread chaser or a tap through everything, clean them all up. This one came apart really good, everything's clean, so I should be pretty good once I just flush it with some water and some air again. Alrighty here guys, I got a head bolt stuck up in the vise here. You can kind of see some of that slimy stuff, that goop that's on the threads. That's some of that thread sealing I'm talking about, and you know, it mixes with the coolant and everything. We can take it out. So what we're gonna do, got the old trusty Milwaukee here with a cutoff wheel, and we're going to cut probably just two of them. We're gonna go this way up the threads and just cut a slot. And what that's gonna do is, as we're running down through there, just think of it like a tap where you have the slots cut in between them. That's all we're doing, is making a thread chaser with this and just allowing the edge of those threads to kind of cut and clean all of the sealant and Loctite out of those bolt holes. So we're gonna go ahead and do that real quick, and we'll go over and get the block cleaned up the rest of the way. Alrighty, so have the slots cut in it. I just cut two. Try and cut it the full length of the thread so you make sure that you get everything. Now be careful. Yes, I'm going to use an impact, but I'm going to run it on low. Don't just try and burn this thing down through there, because you can damage the threads if you're being too aggressive with it. So just be light. If you don't feel safe using this or an impact of some kind, just do it by hand, but make sure you run it all the way down. Now don't try and burn the thing in the bottom, because you will bottom the hole out and you can damage the block, pull threads out of it, whatever. Okay, so you can see some of the dirt and junk that comes out of those holes, and so just make sure you get all those nice and clean. We're going to give this thing a good rinse job afterwards, and we'll be all good to go. And so just for FYI, like, you might have heard it kind of bumping on the bottom, but I only have this thing, I don't know if you can see the light, I only have this thing set on like the super low, and that runs it down to like 5-10 foot-pounds at best, and it'll only hit 10 if you sit there and like bump it. As soon as it hit and started jiggling, I stopped, back it up, run it in again. Alrighty, so sorry for the noise. That's what I got to work with. It's noisy, but so I decided to go ahead and do some wire wheeling and clean this off, because in the next video we're going to be painting this engine, and hopefully it turns out really good. I hope y'all like it. I'll give you a little bit of a hint, but we're going to be kind of keeping the theme going here. So getting this thing blow dry, you can already see we're starting to try to get a little bit of flash rust in there. That's not that big of a deal. That stuff's so light, if you just wipe it with a rag, it'll come out. So try to do this on a cool day if possible, and I actually recommend you not using hot water. Reason being, it dries quicker. That block will soak up all that heat. It'll dry quick. You'll get flash rust almost instantly. As you can see, I'm sweating. It's about 90 and it's pretty humid today, so but we got to do what we got to do. So all right, we got the rods and the main caps I already sent them through the bath, got them all cleaned up. I've cleaned the bolts up. We're not going to be reusing those. I got new ones, but I am going to be using them at least for the part where we're going to install the mains, check all the main clearances and all that stuff. I also have new rod bolts. They're just stock replacements for everything. I didn't really feel the need for this engine to spend the money on ARPs. If I was spending the money on ARP rod bolts, I'd probably just put an aftermarket rod in it, just because by the time you put a rod bolt in it, have them resized, you could have bought aftermarket rods. We really are not going to a power level that we're going to necessitate main studs or from ARP or anything like that. The oil pan, I got the windage tray, I got the front cover, I got all that kind of stuff in there. Valve covers, rockers, all in there, going for a bath. I won't bore you much with that. I'm gonna go through and just get it scrubbed up, clean, and then we'll be ready to go with assembly on parts. The crank is in here in the bag, so it's already pretty clean. I'm not too concerned with it. I am going to just take some of those brushes that I got, and I might show that real quick when we're getting ready to set our clearances and actually put it in and install it for good. So what I've done already off camera, as you can see, this looks a little bit different than when you saw it last time. I got everything painted up nice and pretty. After I was done cleaning it in the last video, I tried scuffing and doing some cleaning on it, and I just wasn't happy with how it was coming out. I figured, hey, it's out, and I feel like I did a poor quality job if I just put it in as it was with dirty grungy aluminum, and I wanted to clean all the corrosion stuff off of it. It just wasn't turning out very good. So what I opted to do was go ahead and sandblast the outside of it and clean all the parts up. So we went ahead and did the valve covers, valley pan, oil pan, the heads, the block. Most of all the big parts are done. So I went ahead and sandblasted, and unfortunately that led to me getting to re-clean the block again, as I showed you before, but at least I know it's nice and clean this time. It's been cleaned twice, so just wanted to make sure we didn't get any sand from the sandblasting or dirt or anything like that back in it. So I went ahead and just did a full clean job just to be safe. So now this is what we're left with. If you can't tell, this is the same color as the truck. I had some paint left over from some previous repairs on it, and so I had the same red and I had some clear coat left over, and I chose this gray on the oil pan. This is on the oil pan, on the valley cover and the valve covers. So I went ahead and went with this color, and everything is primered, painted, and clear coated, all with automotive grade stuff. So this should last forever, should last good. Hopefully we don't have any issues with it like peeling or cracking from the heat later. Some of the guys on Roadkill, Dulcich, and Freiberger swear by this stuff. Doing automotive paint, it's my first time doing it. I've done a couple rattle can jobs with some, duplicolor engine paint, stuff like that. Doesn't seem to last the best, but so we're gonna find out if this lasts any better, stays shiny, looking good. So that's that. In this part, we're going to be getting the bottom end set up. So I've done a lot of painful stuff kind of off camera here. Things that I'm not really gonna get into too much just because I didn't have the time. I was doing a little here, a little there, and it was really sporadic. So we went ahead, we measured the cylinders and made sure that they're pretty square. I got a couple 10,000ths variants. They're all pretty straight. The hone job is pretty good on it. So I got that all checked, measured the skirts, pulled all the rings off the pistons, measured the ring gaps, made sure we're all good on that. I just set the crank in, and I know I'm going to catch some flack for this, but I just plastic gauged it because I really didn't, I wasn't super confident in my micrometer setup that I have right now, getting dial bore gauge straightened out. So I didn't feel like dealing with all that. This is a stock crank that was polished, and I just put stock replacement bearings back in it, so it shouldn't be that far off, and it's not. We're about 2,000ths on the mains. Got the front two are a little tighter, like 18 or just a tick under 2. So I'm pretty happy with that. I figured this thing was going to be a little looser than that, but I'm not mad about it. The crank was polished and stuff, so went ahead and checked that. Got it all lubed up. We're going to drop the crank in, torque the main caps, we're going to put new bolts in it before we torque it, and then we're going to start assembling rods and pistons, get those in, check the rod cap torque, or the rod bearing clearances, and then we're going to keep going together with it. So that's going to be, this video is mainly just going to be some bottom end assembly and sticking the cam in, a few things like that. So we're going to get this crank stuck in there, and I've been wanting to try one of these. So now you see it like this. So got the crank in. Had to kind of take a pause because for some reason I was struggling to get one of the caps squared and set in there. Kept binding up on me, so we just had to take a pause on it and take it back apart, figure all that out. I think I just wasn't getting it to seat right in the block. I always tap them into place and stuff, but for some reason number 4 was just struggling seating itself in there. So anyway, we got it in here, got the caps all torqued, got the side bolts in and torqued. I put a little bit of sealant on those. These are new main bolts. These are Summits, they're GM replacement bolts. So I got them in there. Went ahead, also when you set these in, make sure that you take a dead blow or rubber mallet or whatever and, you know, tap the crank forward and back and get your thrust seated properly before you go ahead and torque this one. I already went ahead and checked. We got 4 thousandths end play, so we're perfect on that. So now we're going to get on to building rods and pistons and getting those installed. As you can see, once you got it all assembled, it should spin nice and easy and free. So on to the next thing. All right, so in the last part, we got the bottom end together. All rods and pistons are in, bearings are all checked, cranks in, everything rotates nice and free. We got good, we checked the ring gaps, checked the bearing clearances, everything's good. So next part, we're going to be getting into a little bit of the meat and potatoes of this video, and that is camshaft, and then we'll be getting into cylinder heads and the valve train setup, because that's where we're going to make some power with this thing. Not going to set any records really, but that's how we're going to bump this thing up a little bit from a stock 6.2 to something that's going to make a little more power. So let's get started. So here's a few of the parts we're going to be starting with. I have a phaser limiter we need to install. I'll go over that. New cam retainer plate. Always replace these. They got a seal in them. That seals that front main galley, front main oil galley right here. So make sure you replace that, because if that gasket's leaking, you're going to be oozing oil. So that needs to seal. I'm also going to modify this a little bit by drilling a pinhole in the one side here to add a little bit of oiling for our timing chain. Reason I'm doing that, and the reason I think that you should do that, is we are running higher spring pressures, we're running a faster ramp and a higher lift on the cam. There's more load on the timing chain because it has to overcome all that, and we are going to be putting more tension on the chain. Being that I am keeping the VVT in this engine, obviously, since I said about a phaser limiter, we are limited to running just a stock single row chain. We can't upgrade to, say, an aftermarket double roll or anything like that. So in order for me to help ensure that we keep a long life on our chain, I'm going to drill a small hole, very small, in the cam retaining plate to let it spray a little bit of oil and keep some more lube on that chain so we can prolong its life. So anyway, new cam retaining plate. Also, I feel that you should probably keep the stock style kind of leaf spring tensioner if you're running VVT. I'm not saying that you have to, but I feel like you should. GM did it for a reason, and I'm not trying to be one of those guys that think that the factory did everything the best, because there's plenty of things they could improve on. But the reason that I say that is when we're targeting our cam movement with the VVT, a little bit of slack in that chain, and I know it's not much, but you can get a degree or two of deflection back and forth on that chain and kind of make the VVT hunt, I think. So I feel like you should keep the stock style tensioner and not go to like the LS2, LS3 style little block in here, because that'll still let that chain slap a little bit. This will keep a little more tension on it and not let the chain wander around as much. So anyway, that's that. And obviously, like I said, I got a new chain, a new just GM replacement, and I'm going to be replacing the cam bolt just to make sure that everything's working right with our cam phaser. And now I won't hold you any longer, and I got the cam card out, and we'll show you what we're putting in this thing It is a Texas Speed cam, and like I said, this is a VVT cam, so this is their L92 VVT stage 2 camshaft. So it is a 220, 232 at 50 duration, and 600 lift at the valve, 113 LSA, and a 107 intake centerline. So I'm going to talk about that a little bit here, and problems that I have heard of and seen people have issues with when they deal with VVT, and they're like, I'll just delete it. Without getting too in-depth into it, your cam timing makes a big difference on where your power band is. In general, I'm not saying this is always the case, you can go too far, but in general, the more you advance the camshaft, meaning the sooner that you close the intake valve so you capture more compression, the more low-end torque you will have. Now that's not, you can't go too far with that and go beyond that point that you're making any more low-end, but then as RPM comes up and you're trying to make more top-end, shift through the mid-range, you can retard the camshaft a little bit and make it meet the needs of the engine better. So it gives you a little bit broader power band, and the reason I'm doing that is I'm trying to retain as much low-end torque or gain as much low-end torque over the 5.3 as I can with this 6.2. That's why I went fairly mild on the camshaft. I'm kind of riding the edge of what I would put in something on this kind of application. Trying to make it have a good overall power band, pull decent on the top end, but still have good drivability, good low end mannerisms, good torque, not need a big stall converter, stuff like that. So there are, the problems that people run into is there's two different cam phasers. So you need to make sure that you check the part number on your cam phaser and match it to the camshaft that you're ordering. Because if you don't, they're not doweled quite the same, or they're not degreed the same. So if you don't degree this camshaft, which we're going to, and I will show you how to do that on this thing. If you do not degree the camshaft and you have mixed the wrong cam and the wrong cam phaser, your cam timing will be way out of whack and it will run terrible. You will have low power or whatever. You know, you could mix them the wrong way and even have a piston to valve clearance issue, whatever. So make sure that you match the cam and the cam phaser that you're using together, so then things work properly. You don't want to put this thing in, and this is supposed to be a 107 intake centerline cam, and say, I don't know exactly, but if you say you mixed this with the wrong phaser and your intake centerline at full advance is say 115, well, your low end's going to be terrible. It's going to top end decent, but your low end's going to be terrible, and you're going to wonder why it feels like it's down on power. And then especially, it's probably not going to run great on top end if you have your tables set up where you give it, say, you know, I don't know, 7 degrees or something like that of retard. Well, then you went from a 114 to like a 121, which is way too late even to make top end. So anyway, that's why it's key that you make sure you match your cam and your phaser and everything works properly. So we're gonna get started with getting the phaser limiter in, because when you put a larger camshaft in, you have something like 52 degrees roughly, somewhere in that area. I'm not sure the exact number, but I think 52 is the number. 52 degrees of swing on the stock camshaft. That's fine with the stock cam. It's not that big, not that much duration, not that much lift, and you won't have any issues. With a larger camshaft, more duration, more lift, mainly the duration side, you can run into a piston to valve clearance if that thing has if it retards too far, and you're mainly going to see it on the exhaust side. So when your piston's traveling up, exhausting all the air, if the valve closing point is too late on the exhaust side, the piston's chasing that valve up, you will have a piston to valve clearance, and you will issue and you will hit your exhaust valves and bend them. So that's just a little tidbit when you get into these later LSs that have VVT. That's why I specifically have these pistons in it. I didn't go for an LS3 flat top, because I wanted to retain my VVT. I needed to put a piston back in it with valve reliefs on the exhaust side so that we didn't have a piston to valve clearance issue. So anyway, that's enough of that. I'm going to stop rambling and we'll go ahead and get this cam phaser limiter put in, and then we'll move on. Okay, so real quick, just to say show you what I was saying. Yes, the cam can be swung up to, if you read right there, about 52 degrees. So that's a lot of swing, and we move it with this phaser limiter to about 16 degrees. So you still get plenty of fore and aft movement for, you know, from full advance to retard to make it make power. You just have to limit it, because if you leave that 52 degrees, you're going to bend valves. And then this is comp even telling you right here on this page about the two different phaser limiters, which unfortunately I believe I have this one. I'll measure it when I get out here. There's part numbers on it too, but mine's kind of dirty. But anyway, I've cleaned it up, but unfortunately I got a little bit of residue and kind of looks like surface rust, but it's like slime from sitting in the soap for a while. It took a bath too long. But anyway, this came out of an 07 Denali, so this is probably going to be an 07, 08 L92. So I'm probably going to have the wire cam phaser with a little bit more movement in it. So, but anyway, we'll find out when I take it apart. So we'll follow this and we'll take it apart, put our limiter block in, and put it back together. Okay, so going to give you kind of a dumb moment here. So when I cleaned this engine up, I showed you all the whole simple green bath, all that stuff. This thing had a lot of varnish on it, and my stupid self didn't really think about this, but there was open ports into the chamber in here, and we got a lot of gunky buildup. I've tried cleaning it out, but obviously we got this thing completely blown apart right now. I kind of don't even want to use it. So yeah, don't submerge it in a water bath. Parts washer, varnish, you know, clean the varnish off with brake clean or anything like that. Don't let it sit into a soak and be stupid like me. So I'm gonna look around. I had another cam phaser around here out of a 6.0. I'm not sure if it's gonna work or not, or if I can even find it. So I'm gonna take a look around and see. We might just take a break, and I'm gonna go ahead and slip the camshaft in and put the front tensioner and the front camera plate on there, and then I might resume trying to find my other phaser, or we may just order another one at this point. I don't know. So, oh well, live and learn. Could be worse. At least I actually took it apart and realized that and didn't put it on the engine like that. So learn from my mistake. Don't be stupid. So, yeah. All right, so cam's in. I don't have the back plate on yet, so I gotta watch that I don't knock it back and it tries to slide out the rear. So anyway, cam's in. Also, if you've noticed, and you may like have a heart attack on this, but I have a little bit of this left over. Some gear oil. I know. This thing's gonna get an oil change virtually immediately. It's gonna fire up, run a heat cycle, drain it, put a new filter on it, put new oil on. You should do that anyway when you're doing a refresh like this. I'm just not, I could use like an assembly grease, but I just don't want to use something that thick and heavy. In the event that this engine doesn't go in immediately when I'm done building it here, some of the greases can kind of set up, and I don't want to take a chance clogging any of the oil passages if this thing sits around for a few months. I know it sounds dumb, but I have heard of some of these assembly lubes, if you use a thicker grease assembly lube, actually kind of drying out, and I really don't want that. So when this thing goes in, it will be getting a full pre-lube, and I'll show you that. We're gonna either modify a fitting or get a fitting right here, and we're gonna pre-lube it when it goes in the truck and have oil through the whole system before it goes in, so everything will be primed. It'll have engine oil there ready to go. Okay, got our cam retainer plate here. Went and drilled just a small hole in there. It's a 1/16 inch hole. I put it on this side specifically. My reasoning was this is the slack side of the chain, so if I get the oil spray kind of over on this side as it's pulling across over this way, that it should help kind of load the chain up with oil. to help when it's being pulled on the tension side, rather than spraying it while it's on the tension side and pulled tight. That's my theory anyway. Whether it works or not, I don't know. But this will help with chain lubrication. Like I said, this is only a 1/16 hole. I'm not worried about that causing much as far as oil pressure issues. We have a high volume pump, all that stuff. So and also the reason I chose high volume for this, the clearances in it are not that loose. The reason I chose it is because GM puts higher volume pumps on VVT engines because the cam phaser requires more oil flow. So they don't have a low oil pressure condition, they put a higher volume pump on, and this little hole right here is not going to be a big deal. It's just going to help add a little bit of lube to the chain. So we'll go ahead and pop that on there, and I will hopefully be able to find this other cam phaser, or I'm going to have to order one. So anyway, okay, so picking up where we left off after my stupid mistake with not getting my other phaser cleaned out properly, we just went ahead and ordered a new one. So this part number is the late part number. The engine had an early one in it. I did some searching, and I think I should be putting the late one in it actually, because a lot of the cam manufacturers now, they actually recommend if you have an early part number that you buy a later one. Depending on who you get your cam from, that may vary. So anyway, we're gonna break this one down, put our cam lock in it. This is the later one that the directions tell you has less retard in it, like 52 degrees instead of 60 something. So anyway, I'll break this one down, put the block in it, or the limiter, and we'll put it back together, and then we'll get this cam degree and make sure we know where we're at. Okay, so we got the phaser split here. I'm gonna kind of make one complaint. So if you read the instructions and you look at how this cam phaser lock is supposed to work, and I ran this on the other one, I just didn't say it, I guess. So if you look at the instructions, you see right there how the lock piece is supposed to actually, there's teeth that come through it. Well, this looks very sketchy, trust me. Don't do it like I'm doing it, because this thing snaps, it's gonna hurt your fingers. But the depth of the cut on my lock piece is not deep enough. It will not go around the tone wheel and through this turning tool and actually lock in the teeth. There's not enough gap right here for the teeth to actually come all the way through. So that's just where it wants to stay. I'll leave it there. Keep your fingers out of the way. Don't be dumb like me. So anyway, I got it opened up here, and if you do the quick measurements like they say about over here, obviously I have the later one now because I got like 812 thousandths, just a quick measurement with the cheapo micrometers right here. So I know I have the later one with less movement. So anyway, we got it opened up, we're all good. Make sure this is nice and clean before you put it in there. And put your cam phaser block in your cavity, put the back of it back on, make sure you put your lock bolt in so it doesn't fly apart, and you're good to go. There's really not much to it. Just follow the directions, and yeah. So real quick note, I put the block in, make sure you put it in, there's a ledge. If you follow the instructions, you see the ledge kind of goes toward the inside on the phaser block. The ledge right there goes in. And also make sure you pull the right bolts out. So the bolt that goes right here, they call it the pin bolt in this hole. It's different than the other ones. You see they call it the pin because it has a tip that is longer, it sticks out, and it grabs that spring on your, that forces the phaser into full advance, whereas your other ones don't have that. So make sure that you pull the right ones out. It says the one clockwise of that is your pivot bolt, to just slide this out of the way. They do that because they're trying to be safer, because they know that if this spring unloads or if this thing pops apart, then you're gonna go, how do I put all the pieces back together? So anyway, just make sure you unload it correctly so you can get this pin bolt out and leave the pivot bolt in there. It's just a little tidbit. So we got this in, we'll put our bolts back in, and we're all good to go, ready to start timing the cam on this thing. Okay, so as you can see here, we got the phaser on, chain in, all that stuff. So I'm setting it up to degree it and make sure that we're at where we need to be. So this is a Comp Cams degree wheel kit. This one's supposed to be specifically for an LS, but I mean, it works for just about everything if you can adapt your tower to get it bolted up somehow. So anyway, so step one here, I'll just kind of run you through it rather than forcing you to sit through this. So how I'm doing it, you can do this other ways. You can do it with the dial indicator if you want, or you can use the piston stop. The other way you can do it, you can do this with the heads on. You can use a piston stop in your spark plug hole. A couple different ways of doing it. I'm just showing you how I'm doing it right now. So take your lock bar #1 piston and just take, they supply you with a couple of head bolts and spacers. Bolt that on, run your stop down in a little bit here, and roll it till it stops. Roll it backwards the other way till it stops. Make sure you record the numbers and split the difference. And if you leave it on your stop, you would have to take that number, whatever the difference is. And in my case, it was 30 degrees. So 15 degrees. So whichever way you had it rotated, if you were 15 before top dead center, 15 after, whatever. Remember, engine spins clockwise, viewing it from the front. Set it 15 degrees either before or after, whichever way you had it rolled up to stop, and tighten your degree wheel down, and then just do a quick verification of your 0 again, and make sure that you, before you take this off, make sure that you were, say, 15 before and 15 after, and tweak your needle here a little bit and make sure that you get it zeroed where you have actual true top dead center. That is key to making sure your cam timing is correct, is you need to take your time and set true top dead center. After that, it's not that bad. You'll set your dial indicator up here, and you'll set it on your #1 intake, which is going to be the front one on this side. Your exhaust has your relief. That's the easy way to tell on this VVT engine. So set it up. I like to set it on the edge of the lifter, if you can see that down in there, so then you don't have any chance of it riding in the cup weird and skewing your readings. If you put it on the outside of your lifter, meaning this ledge right here, not in the cup where the push rod sits, then there's no chance of you messing anything up with your readings getting skewed. So luckily for us, I went ahead and did that. So then what you'll do is I took 50 thousandths, actually it was about 53, because 353 on my cam card right here, 353 is your lobe lift. So you get your 600 lift when you get your rocker arm multiplication, which is 1.7 on an LS, 1.7 to 1. So 53, 52 and a half, somewhere in there is where my thing was. So I set my needle to 0, I roll it up to peak lift, and then I go from one side of the lobe, go from one side to the other, down to my 0 mark, which is 53 thousandths. Some people will tell you to do 50. Some people will tell you to come 50 off of the base circle. You can do it however you want. There's multiple schools of thought on it. It'll get you the same results, is the point. So then, in my case, I had 150 and I had 65 and a half were my numbers. So then what you'll do, take 150 minus 65 and a half, and that will get you a difference of 84 and a half degrees. Take 84 and a half, divide that by 2, and then add it to your lesser number. So add that to your 65 and a half. So that got us right here. So we're clocked in at 107.75, 107 and a half, somewhere in that area. That's where we're at. Our cam card tells us that we should be at 107. So less than a degree, I'm not going to worry about that. I'm not going to cry about that. There's no adjusting that we're going to do anywhere on that. If you're way off, you may want to verify that you do have this locked on the pin correctly, that you do have your dots lined up. If you're getting numbers that are really out there, maybe you didn't get your dots lined up, your tooth off, something like that. If you're pretty close, like I am with this, I'm gonna leave it be. If for some reason, say you're 3 to 6 degrees or something off and you don't know, maybe there was an issue in the ground your cam, it was off, you can, even with the VVT stuff to help get you set up, why I wanted to check this was you can get crank gears that have offset keyways in them to move your cam timing back and forth. So luckily for me, I can leave the one that's on there on it and go for it. But like I said, even with VVT, to get your intake center line, your base timing right, you can still mess with that. You'll just have to change it with the crank gear, like you would with a adjustable aftermarket set or whatever. They do make them for the single rows, so that's just what you would have to do. Luckily, we don't have to do that. So now that I'm good with that, we're gonna move on. And you can check this. Some places even want to do it on multiple cylinders. I'm happy with one cylinder. I know where my intake center line is, so I know how much advance or retard when we're doing our cam timing tuning. I know where I'm starting with, and I know what I'm doing as I retard the phaser. So, because remember that this thing is parked at full advance, or it's supposed to be anyway. They're supposed to be parked at full advance. So as you add oil via your little valve here in your bolt, when you pulse that solenoid, you're changing that valve movement and you're adding or subtracting how much oil flow makes it into that cam phaser. This cam phaser leaks a little bit. That's why they have a little bit higher volume pump to begin with, because obviously it has to bleed some of the oil through it so it can maintain what it's commanding. Another little thing that I did here that you can do with this, it takes you a minute. It's kind of hard since this is an aluminum block. Some of the engines that are, you can use your magnet base dial indicator and just swivel it. Since this is aluminum, magnet doesn't stick to it. As I check my piston protrusion, we're right at 4 or 5 thousandths out of the block, out of the deck, which is right about where stock spec was. So we know that we need that to make sure we calculate our compression ratio correctly, because if your piston's in the hole, you're going to have less compression. If your compression ratio, if it's out of the hole, you're going to have more. So calculating your compression properly is good to know that. I want to make sure that I had the heads milled, and I want to make sure this cam's pretty small in most people's eyes. So I just want to make sure that even though I had the heads milled, this cam's pretty dinky. I'm not too worried about exhaust clearance with when the cam goes into retard, but I do want to make sure that I have enough piston to valve clearance both ways. So we'll put some Play-Doh on a piston and put a head on here in a little bit and show you how we're going to check that. Before we move on, I'm going to show you one other little tidbit here. So you're kind of wondering why I have this tapered roller bearing. Well, here is the roller out of it. And it just so happens that fits nicely in these AFM holes. So the part number on this is simple. It's an A37 national bearing. So if you snip the cage, pull the rollers out, they fit nice and tight in your, so sorry about that. Anyway, so the rollers have a taper on it, obviously to match the contour of the race in the inner and the outer race that the bearing's on. So there's a slight taper on these. They fit perfect down in the hole. You can see they're sticking up a little bit. So you take a hammer and just tap them down nice and flush. And that's what we're gonna do to block all these holes up. No need to spend, I don't know what they are for one of the block kits with like a rivet or whatever. This bearing I think is something like, I don't know, 10 bucks, 12 bucks, something like that. There's enough rollers in there to do, I think there's enough to at least do 2 engines. So nice and easy, they won't come out. Reason I'm doing that, this thing does have a non-AFM valley plate that I'm gonna be using, but if you look at those, they seal with an O-ring. So rather than solely relying on the O-ring to keep your oil around your lifter, to me this is the best way to ensure that you're not going to have any leaks. They shouldn't leak, but over time the O-rings dry up, they flatten out, whatever, and then this will start seeping some oil. I think that's part of why a lot of people actually have AFM lifter issues in higher mileage LS engines. As part of it, to me, is oil changes. People aren't doing good oil changes. I personally don't think you should be relying on the oil life monitor in the dash of your truck, your car, whatever. I don't agree with that. I think you should do a 5,000 to 6,000 mile change if you're running good synthetic oil. you know, depending on your use. If you got a big camshaft, you're hard on it all the time, maybe you should be dropping that down a little bit. That's up to you, but on a stock vehicle, that's why I think a couple reasons is I don't think they do good oil changes. The lifters get varnished. The other thing that I think happens is they start having low oil pressure issues, either from the pump O-ring, stuff like that, or these seals on the VLOM start to just hemorrhage oil, and you don't get the proper oil flow to make the lifters activate and work the way they're supposed to. One thing you can do, if you're kind of cheaping out and you're doing a AFM delete, knock these babies in there, and there's a hole under your oil pressure sensor. Well, there's a drilling that comes in like this, and it feeds that valve body, if you will, in the VLOM. I've seen, and I don't know exactly what size it is because I'm not using it here obviously, but you can get a like a roll pin, or maybe a piece of brake tubing, fuel line. Well, brake tubing would be too small I think, but fuel line, something like that, and cut a piece. And if you find something that's the right diameter and drive it down in there, then all you have is just your port coming up. It'll feed the oil pressure sensor, and it'll block the side feed that goes to all of your AFM lifter ports. Then you don't have to spend $100 or whatever it is on a valley plate. You can buy the $10 bearing and, you know, whatever, a little chunk of brake tubing or a roll pin or something if you find the right size. Cut it and drive it down in there. Bam, you blocked it off. You don't have to replace that anymore, but save you a couple bucks. So anyway, we're gonna knock these in. All right, so quick and easy, as you can see, all of them blocked off. There is enough to do 2 engines in there and part of a third one. So anyway, nice and easy. Drop them in there, drive them in with a hammer, tap, tap. They fit pretty snug, but they're not too snug that you're beating on them trying to get them down in there. So anyway, that's that. Okay, so now that our cam's degreed in, we know where we're at. In order to check this piston to valve clearance on the exhaust side, I did some quick math. So we have 44 teeth on this cam gear. Puts us at 22 on the crank. If you take 360 degrees, divide that by 22, that gives you like 16.7 something degrees, which just so happens to be 16 degrees is what you should be limited to as far as how far you can retard the camshaft. So what I'm going to do is I'm going to put some Play-Doh on the top of the piston here. We're going to roll the engine over in the fully advanced position, check our intake clearance. We're going to then put the cam on 1 tooth retarded and check our exhaust clearance. So that's how we're going to check full advance, full retard, and that will be our points of least clearance for intake and exhaust. So I'm going to go ahead and get started on that. To get started, we are going to get all these lifters. I'm going to go ahead and get the lifters and the trays in, and I'm going to get them full of oil so I can put a head on, and then we should be able to keep the lifter from collapsing because we have oil in it. So I'm going to get those all doing a quick pre-soak and let them bubble all the air out, and then we can get started with this. So also the lifters I chose, these are Morel's, and they're the 7717. They're an LS7 style lifter, but they're a little higher quality. Morel is a little more particular with their clearances and how they set everything up. So I shouldn't have the, hopefully I don't have the sewing machine problem where it's ticking. We'll be measuring for push rod length later, so we make sure that we put the right length push rods in, which should help that. But so I just wanted a little bit higher quality lifter. We're not doing a high revving race motor making all the horsepower, but I wanted something a little better than a stock lifter, so I chose these. So hopefully they're going to do us well. All right, so we've dealt with all of our cam timing. I talked about that. Now we are checking our push rod length and our piston to valve clearance. I kind of did both of those together. I did a bunch of that off camera because it took me a bit getting a few things straightened out. So what I have here is this adjustable push rod. This is a comp unit, I believe, and they got a little line kind of etched into it so you can count your turns and stuff. So this is a 6.8 to 7.8 inch push rod. So what you're going to do, you're going to obviously get your cam in, get your lifters, your trays, all that. Have your head on here. I already had it on. I've taken it back off. So pop that down through your push rod hole in your head. I got head sitting up over here. So you got your push rod holes on this side. you set your push rod in, you put it in like so. It is a royal pain, at least with this tool, to get the adjustment set up right, because it kind of likes to spin the whole push rod instead of unthread itself. And you're trying to get your fingers in around the rocker arm in here to adjust it. So it takes some trial and error and play with it a little bit. Anyway, the length I came up with was about 7/340 is what this adjusts out to on the base of the cam. So just FYI, if you've never checked your push rod length, you have your lobe where the lifter rides up, and then you have what they call the base circle, which is where there is no lift or there's no lobe. So it's easy to see with the lifter valley off in here at the moment. You can see there's a lobe up right here. This is what you would refer to as the base circle of the cam. Top of the lobe, base circle. So you'll roll it over, you'll see where your base circle is, and make sure that both the lifters are down and seated on the base of the cam. And you will run this out and adjust it and pull it out, measure, and you will get a length. And then you're going to have to, in my case, these Morel lifters seem to want about 50 to 60 thousandths preload. I've seen some stuff back and forth. Anyway, I was measuring about 7/340 plus or minus a couple thousandths from intake to exhaust. They were all pretty consistent. I didn't check every hole, but I did check both of them on one, and I kind of went around and checked a few others. But anyway, about 7/340 plus or minus a couple thousandths. So the push rods that I bought were actually marked as 7/375, but actual measured length is about 7/390, 91. So that gets me right at 50 thousandths, sometimes down to about 48 thousandths lifter preload. So we're gonna go with those. If by chance I'm getting noisy startups, or if I feel like I'm getting some lifter tick, I'll go up to a set of 7/400s just to get it a little more preload and see if that helps it. But we're within the measured what Morel tells you to use, so I'm pretty close. We should be all right. So anyway, that's that. So once I determined that my lifter preload and my push rods were going to be correct, then we moved on to doing piston to valve. Now, how I did piston to valve, there's going to be people telling me I did it the wrong way or this or that. This is just how I did it. So I don't have a set of checker springs right now, and I don't really have the stuff to, well, I do, but I didn't feel like taking these heads apart. So these already are set up with my dual springs. So the problem with a hydraulic lifter to check your piston to valve clearance this way is the plunger will depress. I have these where they were pre-soaked and they had oil in them, but they will still depress and leak off. That's why they have to have constant oil pressure to keep them pumped up. So what I did was head on, rockers on with the new push rods, and put them both in there. And actually it just so happened, at least for me, where mine landed was the little lockout piece that doesn't really work when you do your cam phaser lockout right here. If you pick the rocker up and bottom the lifter out, you could just kind of tap this up in under the valve. Now I know there's gonna be people telling me, oh, that messed up rocker arm geometry and this and that. It's close enough for what we're trying to do to get a number. So I put the head on. I did not fully torque it because obviously I don't want to compress my head gaskets completely. So I put it on and just buzzed them down to about 25 foot-pounds, 30 foot-pounds. And that was enough for me to say that I felt that the head gasket was kind of squished, but not to where I can't use it. So put all the bolts in, snug the head down. Before I did that, I just went and got myself some Play-Doh. Some people will say you have to use modeling clay, whatever. It works. It's 50 cents or whatever for a thing of Play-Doh. So pop a thing of Play-Doh on the piston right here, because this is where your valves are going to be coming in contact. So what I did, put that in there and just simply roll the engine over one valve at a time with your little shim in there, so you have your lifter bottomed and you actually get full valve movement on the lobe of the cam. And rolled it over and did that for intake and exhaust. Then what I did, and I kind of talked about this before, so we have variable valve timing, and the cam will retard. So more it advances, the less piston to valve clearance you have on the intake. The more it retards, the closer your piston to valve clearance. Sorry, I might have said that wrong. The closer or the less piston to valve clearance you will have. The more it retards, the less piston to valve clearance you will have on the intake, and it will work inverse. You will gain more intake and less on the exhaust. If you retard it, you will have a tighter piston to valve clearance on the intake and more room on the exhaust if you advance it. So what I did is I did some math, and you count your teeth. So rather than trying to actuate this cam phaser and figure out what our, you know, dynamic clearance is, or however you want to call this, so you know what it's at both park positions, what I did was, if you do your teeth count on this and you do some math and you read the little instruction booklet from Comp, you get 16 degrees of cam movement. Well, it just so happens that if you back this thing off one tooth, that's 16 point something degrees, 16.7, something like that. So what I did is line it up dot to dot, rolled it over, and did the procedure that I just told you with the little spacer in there, so you got full valve movement on intake and exhaust. Then I took the cam bolt out, dropped the chain down, and backed the cam off one tooth retarded, so you would turn it back one. Put it back on, rolled the engine over, repeat the process with your shim so that you get full valve movement. Take the head off, and then this right here is my Play-Doh. So if you measure, oh, got my razor blade in there. If you measure this area right here at my thumb, that is your closest point on the intake. I measured that, and that's like 115 thousandths. And on the flip side, if you look here, you see the little indent for the valve relief in the piston. Our closest point is right about here, and I had 220 or something. I had a lot of room on the exhaust. But that's about how deep that valve relief is. So if you didn't have a valve relief, you'd be getting really, really close. That's why you have to use this kind of piston when you're doing variable cam timing. So anyway, I have tons of piston and valve clearance, and my push rods are good. So we're ready to just put everything else back together. All the hard work's been done. The only thing else that we're gonna have to do any kind of measuring or thinking about is driving our front and rear main seals in, putting the oil pump on, stuff like that. But I'm still gonna go over all that. I gotta get my plug drove in the front of the block here. I got a soft plug kit, so we'll have to drive that in. I can get the oil pump on, get it shimmed and spaced correctly so we don't have any oil pump binding. And then put the heads on, torque them, and I have to finish doing my rocker trunnions, because I did get a BTR rocker trunnion kit because the stock trunnions kind of suck on these things. They limit your valve train movement. If you see right there, you see how that center bar will limit your lift. And if you do a little bit of researching, you'll know that these things are kind of known for coming apart at times and sending needle bearings through the engine. So put the BTR kit in there with a little snap ring. Yes, there's still needle bearings, but there's literally no way for them to escape. And also, there is no limitation to movement other than when the rocker arm bolt hits the rocker itself, which is going to be way more lift than anybody is going to be thinking about running with a stock style rocker arm, or I don't even know how much it would be, but it'd be a lot. So I got to finish doing all of these. That's pretty easy. The instruction from BTR will tell you how to take them apart and do all that. It's pretty easy. How I've been doing it is with this socket and this socket. Use the small one as a die to press that out and into the big one. So you will squeeze it together like that in the vise, and it will shove those out. They pop out. And then BTR sends you a couple of these washers that is the right size to slip over the trunnion bar in the center. And when you squeeze it together in your vise or press or whatever, it will put the bearings in flush to the side of the rocker arm. You put your snap rings on, bam, you're done. Really not that difficult. Takes a little bit of time, but it's pretty easy. So that's the next one of the other big things that if you're doing a cam kit, spend the $100 or so and do your rocker trunnions. I was kind of dumb and I didn't watch the kit that I bought. And if you'll notice, there's no rocker arm bolts in there. So that was my bad because I didn't pay attention to which one I ordered. I just seen the trunnion kit and ordered it, and I ordered the one that doesn't come with rocker arm bolts. And I personally don't trust these stock ones for any kind of decent camshaft. Unless you got just a small low lift truck cam. I personally don't trust these to not snap and break off in the head, especially if they've been reused once or twice. So I have ordered a set of BTR's bolts that goes with that trunnion kit. So that's my bad. Make sure you pay attention to which kit that you're ordering and get the one with the bolts and save yourself the hassle. But so yeah, we're gonna probably go ahead and bolt the heads on and torque them, and then I'll work on the oil pump, putting the covers on and all that. And we're gonna have a long block and be ready to go. So enough rambling, and let's do a little bit of time lapse and maybe torquing these heads. Anyway, so heads are on and torqued, all up to ARP spec. Just a little note, most of you may know this, I don't know, but ARP tells you that you have to use their Ultra Torque assembly lube. So when you use their Ultra Torque lube, it is slicker than, say, engine oil or something like that. I had to use these. I swear I have one of the tubs with a brush around here somewhere. Can't find it. Anyway, there's head bolt part number 2. Anyway, in the instructions, they tell you to make sure that you lube the underside of the bolt head, not the back side of the washer. So the surface that should be lubricated is the surface between the head bolt and the washer. And you should also put a nice bit on the threads and kind of smear it so you have good coverage as you run the bolt into the block. You want the threads lubricated, you want the underside of the bolt lubricated. They tell you that they don't want the underside of the washer between the head lubricated also. They tell you that because they say it creates like a bearing-like surface and your torque readings will be inaccurate. You will actually have stretched the bolt too far. That's what they say. They're smarter than I am when it comes to fastener. They build them, they know about them. So just make sure that you don't just cover the washer, because most of your friction is actually under the heads, not necessarily on the threads. Yes, there is friction on the threads, but I've been told from, you know, places like that that there's actually more friction going on the surface underneath the head of the bolt or the nut rather than actually on the threads. So if you make that bearing-like surface, your torque reading, you will stretch that bolt and turn it further in because of that. So just a little note, that's what they tell you what you need to follow. So the heads are on and torqued. I'm going to probably pop the valley cover on real quick and get all that stuff out of there. If you port your own heads or you get somebody to port your heads, make sure that you see the light through that hole. That's your intake rocker bolt. Make sure you put some thread sealant on that when you put those in. Every single one of these pokes through. That's just how virtually any of your porters, especially on these rectangle ports, are going to do it. You can actually kind of see it right there. You can kind of see the edges of the threads. Every port, there's a bump in there from the factory, and when they port them, they cut that bump out, and then you're left with that exposed hole. If you don't seal that hole with the threads in the bolt when you put that bolt in, it will suck oil, because remember, this port's under vacuum most of the time, unless all you do is drive wide open, and nobody can do that completely. So you're gonna have vacuum in here, and it's gonna suck oil around the threads of that bolt, and you're gonna have an oil burning issue. So just make sure you seal those up. So anyway, all right, so I'm going to put my valley cover on. Just thought I'd give you another little bit of information why I personally think it's important that you drive some plugs in here. I showed you the cheap bearing and how to do that. So this right here is one of the little O-ring seals that goes in that valley cover. This thing is stiff as a board, and you see how this thing's all flattened out. That's not going to seal. This is like almost, I can't squeeze that thing. I can't do anything with it. And this is your replacement, and you can see it wants to move nice and soft, but eventually that's going to dry out over time or whatever. So that's why I personally feel you should mechanically plug these with a steel slug or whatever, like that bearing roller. So when these eventually dry out, it helps you maintain your oil pressure. I'm still going to put these in. Technically, you probably don't need them since these are plugged, but just put them in anyway. They're in your gasket kit. So just another little bit of information.